Chapter 6.3, Part 1, the graphs of sine and cosine functions. So using our unit circle, we are going to fill out the output values for all of our input values that are in radian mode on the left side of the table. So at negative pi, we have an output value for sine at 0. At negative pi over 2, negative 1. 0, sine is 0. Pi over 2, positive 1. Pi, 0. 3 pi over 2, negative 1. 2 pi, 0. 5 pi over 2, 1. And 3 pi is 0. So now we are going to graph these points on the axis that is labeled for you below. So at negative pi we have 0, negative pi over 2 down at negative 1, 0, 0, pi over 2, 1, pi, comma 0, 3 pi over 2, negative 1, 2 pi, 0, 5 pi over 2 is 1, and then it's off my page. Oh, nope, there it is. Pi over 3, we're also at 0. So if I were to connect these, it's going to look something like this. And then it continues on both ends with arrows because this is a continuous function. Okay, so let's answer those questions at the top of the page. So the domain of this function is all real numbers, negative infinity to positive infinity. The range is negative 1 to 1, and it includes both of those because we actually touch those values. So the period. The period is also known as the length of one cycle. Basically, we're saying it's the length before the graph repeats itself. So we always start at 0, and if I draw a box around one cycle, from 0 to 2 pi is one full cycle. And after 2 pi, it repeats itself like it was when we started at 0. So in this case, our period, the length of one cycle, is 2 pi. Now the amplitude. The amplitude is our vertical distance from the center to the min or max. So if we look at our min or our max, so this, let's say we're going to use this point right here. So from the center of my function to the max, we have a value of 1. Now, this can also be figured out by the little formula. Amplitude is equal to your max minus your min divided by 2. So in our case, our max is 1 minus our min, which is negative 1, divided by 2. And we get 2 over 2, so 1, meaning our amplitude is 1. And the last part is symmetry. So we've talked about symmetry before, and this sine function has odd symmetry. And if we recall what that means, odd is f of x is equal to the opposite output if we put in the opposite input, negative f of negative x. Okay, so now let's look at our cosine function. So again, with the table, negative pi, cosine is negative 1. Cosine at negative pi over 2 is 0. Cosine at 0 is 1. Pi over 2, 0. Pi, negative 1. 3 pi over 2 is 0. 2 pi, 1. 5 pi over 2 is 0. And 3 pi, negative 1. So, if we were to plot these values on the grid below, negative pi is negative 1, 0, 1, 1, 0, negative 1, 0, 1, 0, negative 1. And if we connect it, it's going to look very similar to sine, but slightly different. And the main difference is that cosine intersects through the origin. Sine intersects through the origin, and this function cosine intersects through the point 0, 1. Okay, so let's analyze the domain and range, which is the same as our sine function. The period in this case is also 2 pi. It's just going to look a little bit different. And we still start at our x-axis. And our period is at 2 pi. It's just where it starts back over looks slightly different than sine. Our amplitude is also 1. And then in this case, we have even symmetry. And even symmetry is where we can reflect it over the y-axis. And in other words, our original function is equal to the same output value as if we plugged in an x value that was the opposite. Another thing to note at the bottom is that the zeros we have here are halfway between the minimum and the maximum. Okay, so this next part is pretty much the same thing we just did. I just want to list out on the left-hand side how you sketch these graphs. Like, what are the things that I personally am looking for? And I'm not going to actually sketch them out because you just have them on the first page that we just took notes on. So, so just maybe make a note of the steps in order to graph these functions, and then if you want to go back and add those graphs on the right, go ahead and feel free. All right, so the first thing you need to note is that it says 0 from pi over 2. So if we graph sine from 0 pi over 2, this pretty much says I want 1 period. Okay, because from 0 to pi over 2 is 1 period for the sine parent function. All right, so step number 1, you're going to label the x and y axis. So we know that our y values are going to be negative 1 and 1, and then our x values have to be each value that is contained in the period. So if one period is the 2 pi, we need to also include pi over 2, pi, 3 pi over 2, all the way up to pi over 2. All right, the second part is to plot the values at those intervals that I just described. So we have 0, 0, pi over 2, 1, pi, 0, 3 pi over 2, negative 1, and then our last one is 2 pi, 0. And again, these points are coming from that table that we just created on the first page. So then the last part of this is to sketch a curve. So you're going to sketch the curve so we have pi over 2, 1 as a max and 3 pi over 2, negative 1 as a minimum. And if you look at the graph you have on the page before, all of these things apply as we graphed it. For cosine, the same 1 and 2 steps, the first and second steps above, is what you follow, except here, for part 3, we have the point 0, 1 and 2 pi, 1 are maxes. And then pi -1 is a minimum. So that's the difference between sine and cosine, but you graph them the same way. Now we're going to lead into transformations, and we're going to begin with the amplitude. So the amplitude is the number that is in front of our sine function, like you see in that box, and then I also added in how to figure out the amplitude based off of our min and max values. So that 4 in front of sine t, what does that mean? That 4 is a vertical stretch. All right, so we vertical stretch by a factor 4. Now, what does that also mean? So we need to stretch any stretch, so stretches relative to the x-axis meaning a vertical stretch is relative to the x-axis, meaning we're going to pull up away from the x-axis. So therefore, what that does is our zeros remain the same, but our extremas, so our mins and maxes, move based on the value of our stretch. So in this case, move to 4 and -4. So what would that look like? Well, instead of at -1 and +1, we are going to have -4 and +4. So this is the top part of our graph, and I'm going to extend this line so that we know this is how high and how low we are going to go when we graph our coordinate points. So our zeros stay the same. So I'm going to label, we have 0, 0, and then pi over 2, pi, 3 pi over 2, and 2 pi. So since this is a sine function, we have a point at 0, 0, so sine at 0, 0, and then we have pi over 2, but now instead of being at 1, it's at 4. Pi is at 0 still. 3 pi over 2 is now at -4, and pi over 2 is at 0. I'm sorry, 2 pi is 0. So this is one period. That's always going to be expected of you at least one period of our sine function with an amplitude of 4. Okay, so then if we have a -1 a value. So what this is a vertical reflection, just like we know from before. A vertical reflection. And what that means is it's over the x-axis. So we're going to take cosine now and just flip it over. So that means that I still have a range of -1 to +1. However, Oh, and I still have the values pi over 2, pi, 3 pi over 2, and 2 pi. However, our points are, instead of being at 0, 1, we're at 0, -1. Pi over 2 is at 0. Pi is now at +1. 3 pi over 2, 0, and pi over 2 is now at -1. So if I were to connect these, you would notice that it looks like the cosine function, but it's just flipped, reflected over the x-axis.